Hi there, welcome to my channel Mando to Fundu. In this video, I am going to discuss about the solution for finding the sum of root to leaf numbers problem. Let's look at the problem description. We are given a root of a binary tree which containing the digits from 0 to 9, 1. And then each path in that tree represents a number. We have to find the sum of all the numbers represented by the each path to the leaf node. And the answer will fit in 32-bit integer. So let's take a look at the example 1. So in this case, there is a path to the leaf node 1 and then the leaf node 2. So this path represents the number 12, this path represents number 13. So the result will be 12 plus 13, 25. And in this example, so the path to the leaf node 5 represents the number 495, and for the leaf node 1 is 491, and for leaf node 0 40. So we have to add all these three numbers, so therefore the sum is 1026. So number of nodes in this tree is ranging from 1 to 1000, and node values are ranging from 0 to 9, and the depth of the tree will not exceed 10. Let's look at the approach to solve this problem. So we are given this input tree which has 3 nodes, 1, 2, 3, and this path represents value 12, and this path is 13, so the sum is 25. We can solve this problem by doing the level order traversal on this tree. And as we traverse each level, we keep track of the numerical value of their parent node by pairing that the numerical value with the root node and add it to the queue. Okay, so whenever a particular node is processed, we refer the numerical value of its parents and multiply that number by 10 and then add the current node's value to form the numerical value of current node. So as we go down, each digit is shifted left. Okay, so first we initialize the sum to 0, and then we initialize the queue with the root node, and the numerical value of the root node's parent is 0 because there is no parent, so we start with 0 as the parent node's numerical value. So when we do perform the level order traversal, so whenever a node is traversed, first we compute the current node's numerical value by multiplying this node's parent value by 10 and then add that node's value. For example, when we traverse this node, we have its parent's numerical value as 1. So when we process this node, first we multiply 1 by 10 and then add this value. So that gives this node's numerical value as 12. Okay, so this is the first thing we do. So that's what I mentioned here. Compute the new number by multiplying the parent node's numerical value by 10 and then adding the current node's value. And then we check whether the node being processed is the leaf node or non-leaf node. If it is a leaf node, we simply add the new number to the sum variable. Otherwise, we check whether it has a left child. If so, we add the left child node with the recently computed new number as a pair and add it to the queue. Same way, if it has a right child, we add the current node along with the parent's numerical value, which is 1, and add it to the queue. So when the level order traversal algorithm picks up this number, it will check whether this is the leaf node. If so, it will multiply this by 10 and add this value and then add that numerical value to the sum. So when we finish the level order traversal, finally we have the sum of all the numbers formed by the path in the tree. Let's look at the flowchart. Input for this procedure is the root node. First we initialize the sum variable to 0. Next we check whether the root node is null. If so, we simply return the sum as 0. Otherwise, we initialize the queue and add the root node comma 0 as its parent's numerical value pair to the queue. So each element in the queue is a pair of a node and then its parent's numerical value. So for the root node's pointer and the value 0. Then we are entering the outer loop of the level order traversal. In this outer loop, we check whether the queue is empty. If the queue has some element, then we get the current number of elements in the queue len variable, and then we enter the inner loop which process all the elements in that level, current level. Okay, so this loop runs until the queue len is greater than 0. First we dequeue the element from the queue and then we compute the new number by multiplying the parent number associated with this node by 10. Basically we are shifting left one digit and then we add the current node's value. So this operation computes the current node's numerical value for the path starting from the root to the current node. Okay. Then we check whether that current node has a left child. If so, we add that left child node along with the recently computed new number pair to the queue. Same for if it has a right child, we add the right child comma the new number pair to the queue. If the current element is the leaf node, then we simply add the new number to the sum. We proceed to process the next element in the queue. So once all the elements in the current level is processed, then we go back to the outer loop. So if all the elements are processed, then we go back to the outer loop until the queue is empty. This operation will be repeated for every level. Once all the nodes are processed, finally when we come out, the sum variable will have the sum of all the numbers represented by the path to each leaf node. Let's move on to coding. First I define the structure for the queue element called queue data, which has a node of type tree node and then a numerical value of its parent node. Next I initialize the sum variable to 0 and then I check whether the root node is nil. If so, I return the sum. Then I initialize the queue data structure with the root node and its parent's numerical value. Because root do not have a parent, I set 0 as its parent's numerical value. And the outer for loop begins. Here I check whether the queue is empty or not. If it is not empty, then I assign the number of elements in that queue to the queue len variable, and then the inner for loop starts where queue len number of elements will be processed. Okay. First I dequeue the first element and then update the queue. Then I compute the numerical value of the current node by multiplying its parent's number by 10 and then add the current node's value. Next I check whether the current node is a leaf node. In this case, I add the newly computed number to the sum variable. If the current node has a left child, Then I add the left child and the parent's numerical value pair to the queue. So the queue data and then the left child and the current node's numerical value. Same for the right child. If there is a right child, then we add an element to the queue. That element will have a right child and the current node's numerical value as a queue data. After processing all the elements, outer loop terminates and finally I return the sum variable. Next I am going to run the test cases. All the tests passed. Next I am going to submit this program. Cool, this program is accepted. Next I am going to do the code walkthrough with sample input. Let's do the code walkthrough for this input, which has 3 nodes and the expected output is 25, this path 12, this path 13. Okay. So first we initialize the sum variable to 0 and then we check whether the root is nil. In this case it is not, so we are proceeding, and then we are initializing the queue data structure with the element of type queue data, which is a pair of node and its parent's numerical value starting from its root. So for the root node there is no parent, so we are starting with the value 0 as its parent's numerical value. Okay, and then we are entering the outer loop of the traversal, level order traversal. There we are checking the queue length is greater than 0. In this case we have one element, so we are entering this outer loop and then we are computing the queue length, which is 1, and we are entering the inner loop. We run queue length times and dequeue that many number of elements and process those elements. So in this case only one element. So first we dequeue the element from the queue and then we are adjusting the queue. Then we compute the current node's numerical value by multiplying its parent's numerical value by 10 and then add the current node's value. So by doing so we are shifting the parent's numerical value 1 digit left and then we are adding the current node's numerical value. Okay, so we just computed the numerical value of the current node starting from the root. Then we check whether this current node is a leaf node. In this case it has both left and right child. Then so we are checking here, if it has a left child, then we pair the left child with the current node's numerical value and then we add that to queue. So if we see here at the end of iteration 0, we check whether this node has the left child. If so, we add this number and its parent's numerical value, which is 1, we computed. So we added 2, 1, and then we check whether it has a right child. Yes, it is. So we are adding 3, 1, the right child, the parent's root node's numerical value. Then we decrement the queue length, so it becomes 0, and sum is still 0 because we haven't seen any leaf node yet. So after processing the one element in that level, then we come to the end of the outer loop iteration 0. So where the queue has 2 nodes and the sum value is still 0. Then we enter the outer loop iteration 1, where we compute the queue length, which is 2. Then the inner loop will run 2 times, process those 2 elements. In the inner loop iteration 0, we dequeue the 2, 1, and then we compute that node's numerical value. So the parent's numerical value is 1. So it 1. So we multiply 1 by 10 and then we add this value too. So this node, the numerical value of this node is 12. Then we check whether it is a leaf node. Yes, it is. So we simply add that new number to the sum variable. So the sum becomes 12. Then we decrement the queue length, so it becomes 1. Then we enter the second iteration, and at that time we dequeue the element 3. So the current element is 3, 1, and then we compute the numerical value of that node by multiplying 1 by 10 and then adding 3. It becomes 13. And then we check whether that current node 3 is a leaf node. Yes, it is. Then we are adding that number to the sum. So 13 plus 12 is 25. And then we check whether because these two are leaf nodes, so we will not be adding any more elements to the queue. Finally, the queue length we decrement, it becomes 0. Then we come out of the inner loop. Then we reach the end of the outer loop iteration 1, where the queue is empty and the sum value is 25. Then because the queue is empty, we come out of the outer loop, and finally we return the sum 25. That is the expected output. Next, I'm going to do the time and space complexity analysis for this solution. For this input has 3 elements. So in order to compute the sum, we have to traverse all the 3 elements in this level order traversal. So the time complexity is order of n. So next, let's do the space complexity analysis. So the space required is the maximum number of elements that can be in a particular level. So in the worst case scenario, the lowest level, which is the leaf node, if the tree is complete, last level has all the nodes in it, then for that iteration we need 2 to the power log n number of nodes in the queue. We need to allocate space for that many elements. So the space complexity is order of 2 to the power log n. Thanks for watching this video. Have a great day.